Hello guys, welcome to my channel Algorithm Avenue. In this video, we'll be seeing the code implementation of the perceptron loss function. In the previous video, we have seen the perceptron trick, what are the disadvantages with the perceptron trick, and why is the loss function introduced, and different methods to calculate the loss. And we have seen the perceptron loss function and hinge loss function. Okay, what are the disadvantages in the perceptron loss function so that hinge loss function is introduced. Okay, now let's implement our perceptron loss function, that is hinge loss function, in the code format. Okay, I'll be also implementing the code with the perceptron loss function as well. Okay, but let's first initially see the hinge loss function. Okay, now import torch. The import torch is a basic library. As I have told you in the previous code implementation of the perceptron, the import torch is a base library which provides you help you work on the different tensors. Okay, this import torch.nn as nn will help you work on different neural networks, means help you build different custom neural networks. Okay, now we are creating a class. Okay, we are creating a class inheriting the nn.module. nn.module helps in creating the custom classes and also keep in track the model parameters, and also helps in automatic backpropagation. We are also defining constructor in the perceptron loss function, because as a perceptron loss function or hinge loss function is not a built-in loss function in the PyTorch library, means PyTorch framework, this hinge loss function, perceptron loss functions are not inbuilt. We need to specially define and fit to the PyTorch framework. So we are defining the constructor. Next is super.init, which helps in training and testing and reloading and moving the model from one device to another device. We use this super.init. Next is def forward. We have taken self and logits and comma labels as your arguments. Now here we are creating the loss function. Okay, labels.float means it converts them to float data type, and this is your loss function. Torch.tensor 1 0 comma means max of 0 comma 1 minus labels.logits. Okay, means you are multiplying labels into, labels are your true outputs and logits are your predicted outputs, and then you are returning the loss. Okay, now here you are defining the model. Okay, same as in the previous code implementation, in the similar way you are defining the model. Okay, with single linear layer, means one perceptron, single perceptron model. Okay, this is your forward method. Self comma x is your input data. Now you are taking inputs. For these inputs, the corresponding labels are these. Okay, for these inputs, these are your labels. Okay, one second, labels. Okay, for these inputs, these are your corresponding labels. Then you are defining your model, means this is the object. Okay, this is a model object. In the model object you are sending 2. This 2 is your input size. Okay, the 2 goes directly here. This 2 is your input size, and the model is built on 2 input size and 1 is your output size. Okay, now here you are defining the loss function, that is perceptron loss function that you have created here. Okay, this is your perceptron loss function, and the loss function is defined exactly over here, and optimizer is used to optimize the weights. The optimizer you are using is stochastic gradient descent. Now this is your training loop. From here to here is your train. Okay, this is your printing the model results here. Okay, now in this training loop, these logits are the raw outputs of your model, means directly you are sending these inputs. These inputs are directly sent to this model, and the logits are the outputs of this inputs. Okay, the inputs are directly sent to the model, and the model's output are the logits. Okay, now the loss is calculated between logits and labels. Okay, now these logits and labels are the arguments, means directly when you define your loss function here, where these logits and labels go, the logits is calculated here, you have the labels over here. Okay, you have the labels over here. Okay, you have, these are your labels and these are your logits. These logits and labels directly go here, directly go to your forward method. Now the loss is calculated between both these logits and labels. Okay, why this mean is used is when you have n number of inputs, the average loss is calculated. Okay, for n number of inputs, the average loss is calculated, so you have used mean here. Okay, the labels and logits have come from this step. Okay, this step, the labels and logits are your arguments, and they have directly gone to the perceptron loss function. Okay, where you have defined it, there it has gone. Now this is a optimizer, you are going, this is backward propagation, and you are updating your weights here, and this is a part where you are printing your data. Okay, now this is not required because this is just for test cases, means just you are printing on some test data. Here you are training and here you are printing on the test data. Okay, now one last time we'll be seeing the flow. Here you are defining the loss function. Now here you are defining the model, and these are your inputs and these are your labels, and the model object is created here. Okay, with the input size 2, this 2 goes directly over here with 2 input size, and 1 is your output size, means 2 inputs and 1 output your perceptron model is currently working on. Now loss function is perceptron loss. Okay, what the name you have given here, the similar name should be given over here as well. Okay, this is a loss function, is your perceptron loss function, and this is optimizer to optimize the weights, and this is your training loop. In the training loop you are calculating the logits. Logits are the model's raw outputs for the corresponding inputs. Okay, the inputs are directly sent to the model and the logits are calculated. This squeeze is used to remove the unnecessary dimensions. Okay, now the loss is calculated between logits and labels. Okay, these logits and labels directly go here to the forward method. Okay, and here the loss is calculated, and this loss is directly written here. Okay, now the loss is written here. Now you set to the parameters to the 0, and you do the backward propagation, and you update the weights, and you print the model results. Okay, now let's run the data. Okay, you see that initially the loss was 0.6434 for 10 epochs. Now when you directly go to the 100 epochs, the loss has become 0. Okay, means your model is learning from the data, and constantly as it is learning, it is updating its parameters, and the loss is minimizing. Okay, in this way the perceptron loss function works for hinge loss. Now for the perceptron loss, you just have to remove this one and rerun the data. Okay, when you rerun the whole cell, this is your perceptron loss function. When you use the perceptron loss function, these are your outputs. Okay, when you use an when you add one here, when you add one over here, then it becomes your hinge loss function. When you remove the one, this is your perceptron loss function. Okay, hope you understood the implementation of perceptron loss function. If you like the video, please like, share and subscribe the video. Thank you.